Hi, today we'll be going over section 7.3, hypothesis testing for the mean with sigma unknown. Again, what we mean by sigma unknown, we're referring to our population standard deviation. An introduction. As we continue our exploration into hypothesis testing, we are going to apply a similar reasoning as the last section, and we'll apply it to the population standard deviation when the population standard deviation is not given. We will use similar techniques as we did for confidence intervals with sigma not known. So just to remind you, this was back at 6.2. All right, as we go about this, I'm going to list out the steps to do it manually, but we will use our calculator mainly. When we're using our calculator, we're going to refer back to our 7.2 definition. So recall from 7.2, when our p is less than or equal than our alpha, we're going to reject our null hypothesis. And when our p is greater than our alpha, we're going to fail to reject. And it all comes down to our null hypothesis. Okay, we're going to list out the steps to do it manually. So first we want to find pretty much a z-score that corresponds to our given information. The t-test for a mean mu is a statistical test for a population mean. The test statistic is the sample mean x bar. The standardized test statistic is, so t is defined as x bar minus mu divided by your sample standard deviation divided by your sample size, n. When these conditions are met, 1, the sample size is random, and 2, at least one of the following is true. It's normally distributed or your sample size is larger than 30. If so, then I can determine my degrees of freedom to be n minus 1. Now remember from 6.2 that when we are working with a sample size that may be less than 30, our distribution is a bit off. Mainly our tails are not as close to the line as ideally we would like them to be. So these are our guidelines to finding our hypothesis tests when our sigma is unknown. 1, we want to verify that sigma is not known. The sample size is random and either the population is normally distributed or n is greater than 30. 2, state the claim mathematically and verbally. Identify the null and alternative hypothesis. And I set you up for this every time. Write your claim. That helps you find your null and your alternative, your ho and your ha. Specify the level of significance, your alpha, your given alpha. Identify your degrees of freedom. Determine your critical values. Determine your rejection regions, and that's based on your claim. Find the standardized test statistic and sketch the sampling distribution to compare it against your normal distribution. Make a decision to reject or fail to reject the null hypothesis. Interpret the decision in the context of the original claim. All right, we're going to use a calculator. And the calculator, all that's left for us to do is to interpret our question and know how to label things properly. For our calculator, we have these steps highlighted. To get to this type of particular setup for us, we want to press Stat and then scroll to Test. We are going to choose t-test. I know we've done so many tests by now, but each one has its own, so I recommend you keep track of all of your sections and how they're different. And then you want to fill out these pieces of information. Your mu sub 0 or your mu 0 is the mean that's stated in your claim. X bar is the mean that we are testing it with to compare it to our claim. Sx is our sample standard deviation, and n is our sample size. And then from there, we're left to choose one of three. Our claim can be two-tailed, right-tailed, or left-tailed. If unsure, then look at your alternative, your ha. The sign will tell you what tail it is. So along with your calculator, it has these signs, those three signs in green, and you know what tail test to use based on your ha. F, you choose calculate and press enter. 4, the answer you will get is either as a critical value or proportion. Well, you'll get both, critical value and proportion. We want to work with your P, your proportion. That's easier to work with. Recall from section 7.2, and we also wrote in the beginning, this is how we are able to come up with an answer. We compare our proportion P to our alpha, and that will let us know whether we reject or fail to reject our claim or our null hypothesis. Not your claim, your null hypothesis. All right, let's do an example. A used car dealer says the mean price of cars sold in the last 12 months is at least 21,000. You suspect the claim is incorrect and find the random sample of 14 used cars sold in the last 12 months has a mean price of 19,189 and a standard deviation of 2,950. Is there enough evidence to reject the dealer's claim? And with a significance level of alpha equals 0.05, assume the population is normally distributed. All right, so how do we know it's a 7.3 question? Two things. Notice we weren't told it was a population standard deviation. Second, we're given a sample size. Those two things are a big indicator that this is a 7.3 type of problem. All right, let's go ahead and find our claim. Our claim is given in the beginning. It says that, so when we're doing hypothesis testing, we're trying to prove if whatever they're saying is true or not. That's what we're testing. We're testing their claim. So they're saying that at least 21,000 cars are sold. So at least. All right, how do we interpret that as a math symbol? At least is greater than or equal to. So we have a mean that's greater than or equal to 21,000. All right, now we're left to find your null and your alternative. I call them ho and ha, just to make it easier. All right, your null always has your equal to. So your options are greater than or equal to, less than or equal to, or equal to. Because we have an equal to that belongs to your ho, your null. So we're going to write mu is greater than or equal to 21,000. Your ha is the opposite without an equal sign. So we're going to have a mu of less than, not greater than, 21,000. And we're going to keep in mind that we have a significance level of 0.05, an alpha of 0.05. Okay, let's go ahead and do our work. So we're going to be using our calculator for this. For a calculator, you have the list above. So you want to go ahead and press Stat and scroll to Test. Then you want to scroll down and choose T-Test. From there, you have these pieces to fill out. Mu sub 0, X bar, sample standard deviation, your N, and then your test. Okay, in this case, our population, our claim mean is 21,000. Our X bar, we were told the mean to compare it to is 19,189. 19,189. We were told the sample standard deviation is 2,950, and we had a sample of 14 cars. Okay, now we have to choose our tail. Look at your alpha. We have a greater than, right? So we're going to choose the one that reads like this with a less than sign. And again, if you're ever unsure, look at your alternative. That's the same symbol that your tail test is. All right, you press enter and we get our answer. We get an answer of P is equal to 0.0194. It's long, right? So you can round. Our P is 0.019, or we can say 2, round to 2 decimal places. That's a big part of our answer. Now, the last piece, we want to compare our P in correspondence or compare it to our alpha. We were told our alpha, we have it highlighted in red, is 0.05, and our answer P is 0.02. Which one's larger? Use an equality sign. And we get an answer, well, we can think of what's more, 4 cents or 2 cents or 5 cents. 5 cents is more, right? Because we have a less than, we reject. You reject the null hypothesis. And that's your answer. You did all this work to compare it to this. And then you want to take the time to rewrite it in terms of your argument. So you can say that you reject the claim that in the last 12 months, at least 21,000 cars were sold. Now, I like to use P and compare it using an inequality, but what it's saying is if you choose to, you can always do a bell-shaped curve. And we have we have a alpha of 0.05. So we want a 95% confidence, since that's 5%. Maybe I should write this in decimal. This would be 0.95. All right, and anything that falls around 0.05 or near it, on it, or below, we reject. So this is our reject section, and if it falls anywhere above that, then you fail to reject. Okay, our answer was P is 0.02. 0.02 is somewhere over here. So it falls in our reject section. So we get the same answer, right? But I really prefer to just do this. Take your P and your alpha and write some inequality. And you have two options, right? And you have a rule. And we have our rule listed above in the beginning of our text. Let me jump to the front. We have it highlighted. If it's less than or equal to, we reject. If it's greater than, we fail to reject. I feel like that's much simpler to work with. All right, let's take a look at our last example on the very last page. Let's read our example. A Department of Motor Vehicles office claims that the mean wait time is less than 14 minutes. A random sample of 10 people has a mean wait time of 13 minutes with a standard deviation of 3.5 minutes. At alpha equals 0.10, test the office's claim. Assume the population is normally distributed. All right, so we have that important wording. It's normally distributed. We can go ahead and continue. Our claim is the mean wait time is less than 14 minutes. It's less than 14. All right, from our claim, we get to write our ho and our ha, our null and alternative. Your null always has the equal to option. Your ha has the not equal to. All right, because our claim has the sign with strictly less than, our ha is just like our claim. And therefore, our null is the opposite sign, so it's greater than or equal to 14. And that's how we set up our null and alternative hypothesis. Let's go ahead and continue. So we're using our calculator. This makes this calculation a lot easier without having to use our charts, without having to find our degrees of freedom, critical values, or our z-score. It's much easier to work with. So let's go ahead and use our calculator. So remember, you're going to go to test. You're going to start off by going to stat. Press stat, the stat button. Make sure test is highlighted. And you want to go to t-test. And from there, we're going to fill out these pieces of information. It has them written in this order. Okay, so our mean, the mean we're working with for our claim is 14. And then we went ahead and did a test, and we found that a new mean time of 13. We have a sample of 10 people, and we have a sample standard deviation of 3.5. Now we're left to choose our tail. Your tail is always given by your ha. Because we're pointing to the right, it's right tilt. So we're going to choose the one that looks like this. Make sure that is highlighted and press calculate. And again, I'll leave this note again. If you're unsure of what type of test you have, look at your ha. Our answer is then given as a T if you want to look at z-scores and a P for proportion. We're going to work with P. We're given 1.94 and it goes on for quite a bit. It's round to 1.19. And now we're left to create this inequality of P and alpha. And we want to know which one's bigger, which one's smaller, right? Compare it using an equality sign. We have a P of 0.19 and we're given an alpha. What's our alpha? 0.10. 0.10. Which one's bigger? It's greater than, right? When it's greater than, our answer is then fail to reject. Fail to reject the null hypothesis. All right, and that's it for this section. Now, before you're done with the problem, you of course want to interpret it using your question and the words they use. All right, that's it for 7.3. If you have any questions, please feel free to email me or you can post them in our discussion board. Thank you.